In this video, you will learn how to classify real numbers. On the top of your note sheet, first draw a big circle and write real numbers at the top. Then, on the right side of that big circle, draw a smaller circle, label it irrational numbers. On the left inner part of that real numbers circle, draw a bigger circle and label it rational numbers at the top. Then draw a smaller circle within it and number it integers. Draw another smaller circle within that and call it whole numbers. And then lastly, draw one final small circle labeled natural numbers. This diagram is one representation of how we can classify real numbers and sort them using this graphic organizer. On the left is another graphic organizer that we can use for different types of real numbers. Now let's go over the definitions. Natural numbers are the numbers that we use to count, such as 1, 2, 3, etc. And as we fill in, let's fill them in on the diagram. So for natural numbers, we have 1, 2, 3, etc. Whole numbers are the natural numbers and 0. So it's 0, 1, 2, etc. So you can fill in on our diagram. So we have 0, 1, 2, etc. The next type of number is integers, and integers are natural numbers and their opposites and 0. So it's -3, -2, -1, 0, 1, 2, and 3. So on our diagram, we can label -3, -1, 0, 1, 2, 3. Rational numbers are all the numbers that can be written as a fraction or as a quotient of integers a over b such that b does not equal 0. And these rational numbers also include terminating and repeating decimals. And examples are 1/3 and 1/8. So we can fill in our examples of 1/3 and 1/8. The last type of number we have is irrational numbers. And irrational numbers are decimals that neither terminate or repeat. So examples that have pi or a lot of times square root. So we have pi and square root of 2 as our examples. Now essentially the way we use this diagram is we figure out where's the first place that this number would fall in, and it's going to drop straight through to the correct classification. Using the diagram from the previous page, try to fill in these numbers into the best classification using the definitions we had before. Now -146 is going to fall into integers because it's a negative of a whole number. So I can label this as -146. -52 is also a negative of a whole number. So I can put -52 in as a whole number. -3 square root of 7, because it has a square root, is an example of an irrational number. So we -3 root 7. Since -2 is a negative of a whole number, I'll fill in -2 as an integer as well. Now 0 is that special case where it's not just a counting number, it's including that number 0. So it falls into the whole number category. 5/9 is a fraction, which means it is a rational number. And if we plug that in the calculator, it would be a repeating decimal. 2, since it's a counting number that we normally count with, starting with 1, it falls into the natural number category. Square root of 5, because it has that square root, falls into the irrational category. 3.8, since 3.8 is a terminating decimal, meaning that it ends, it is a rational number. 9.47, since it has that bar above the 0.47, meaning it repeats, It is a rational number. So I have 9.47 repeating. 9 plus pi falls in the irrational category because it has a pi included. 6 pi also falls in the irrational category because it has a pi. 47 is a whole number, so it falls in the natural number category. And 101 is also a whole number, so it falls in the natural number category. And you want to fill it into the box that best matches the definition. Now for the next example, we want to figure out what is all of the possibilities. So you want to list, include all classifications. Now if we look at negative 6 would first fall into the integer category. So I could start with the integers, and once it starts with the integers, it's going to fall through to rational and down to real numbers. So negative 6 is an integer, a rational number, and a real number. For the next example, the first place that 2 would fall in is into the natural number category. So for 2 is a natural number. It could fall down to whole numbers, fall through to integers, fall down to rational number, and then lastly continue to fall through into the real number category. For the next example, for number 3, 0 first falls into the whole number category. So it starts as a whole number, falls through to integers, falls through to rational, and then finally falls down into real numbers. For the last example, with 0.2 repeating, this can also be written as 0.2 with the line above it, making it a rational number. So it starts as a rational number and falls through to the real numbers. So we have rational and real. For square root of 3, if we plug the square root of 3 in the calculator, it gives us 1.732 0.5 and keeps going. Since it's not repeating and not terminating, this makes it a irrational number. So it's irrational and it falls through to real numbers. For the last example, if we plug in negative square root of 4 in the calculator, that would give you negative 2. The first place that negative 2 would fall into the buckets is for integers. So we have integer, it falls through to rational, and then falls all the way through to real numbers. The next example says your school is sponsoring a charity race. Which group of numbers best describes the number of people P who participate in the race? And if we want to think about possible numbers here, we could have something like 200, 450, 831. All of these numbers would first start as natural numbers. In this case, you're only giving the best group to describe the number. So in this case, the best group to describe this set of numbers is natural numbers. For the next example, it says, if each participant made a donation of $15.50 to a local charity, which subset of numbers best describes the amount of money raised in dollars? Now we could say that we had one person donate, so you could have $15.50. You could have a lot of people donate, so let's say we had $100 donate 100 times 1550. That would give you 1,550. But because we have this decimal right here, this means that we have to start with rational numbers. So our best set I would describe is rational numbers.